So what is this kdevops thing that I'm talking about? It's basically, it's a Linux distribution agnostic solution for test automation and development automation. It essentially is a combination of kconfig, Ansible, CI integration, and an automatic dashboard. It supports local virtualization using guestfs, and it supports pretty much every single possible cloud provider that we can think of that we can test: OCI, AWS, Azure, Google Cloud Compute, OpenStack. Anything that has a Terraform provider we can essentially support. I've tested this both in Terraform and OpenTofu. I've used AWS, I use bare metal. Basically, it really depends on your requirements. Bare metal is something that we're also working on. It really should be pretty simple. It's just not, our first goal was to not support bare metal, but it's really simple to support that. All parts of kdevops have been designed with automation and scaling philosophy. Who's working on it? This shows just a 1 year's worth of development. I'm not showing the previous years because this has been ongoing for like 6 years now. So I'm happy to actually see someone taking the top lead in development other than myself. Previously, it was just me. Now we have different people, and Oracle has been contributing a lot. So I like to thank Chuck for all his contributions. Both Daniel and Chuck have made incredible contributions to the project. kdevops also supports this thing called dynamic kconfig, which basically, as an example of a use case here, would be Linux releases a release every now and then. There's Linux Next tags pushed out daily sometimes. You essentially want proper integration for that into your software configuration, so that way you can select the latest features or latest release of a kernel. You want that dynamically created for you. So these are generated automatically. If you want further dynamic kconfig generation, you can use this other target called dynconfig. One example use case for this was to try to see if we can scrape your PCI tables to allow you to use kconfig to essentially do and enable PCI pass-through support. So this is an example of what this looks like. You basically just enable libvirt PCI pass-through, and then you can go through the selected device that you want to do pass-through, and then just pass this on. One of the complaints that I've heard about kdevops is that it's difficult to do development on it, but so is Linux kernel development. So the philosophy here is that if you've done kernel hacking, it should be actually pretty easy. We tried to make kernel development easier this way as well, too. It reduces the barrier to entry. We have different virtualization defaults for users. This is another challenge. Essentially, what this means is that different distributions, like we have pretty much two forks of distributions. Those who have the QEMU system user sessions, QEMU system session and the QEMU user session. And then you have those users who use virtualization, and they basically just don't want to configure anything. They just know what they're doing. So we basically just try to detect your distribution and try to assume what the distribution uses as a default. Another issue here is security. We basically currently require disabling SE Linux, AppArmor, and we also require sudo, which makes a few people pretty nervous about that, but that's something we could work towards removing. Enabling SE Linux and AppArmor is something that we can also enable. It's just low-hanging fruit. You know, if you're doing testing, you really don't want to be just enabling that right off the bat, but we can essentially do that. We can actually just ask an AI to support, give us support for that. It's not too complicated. It's just not a priority for us. So essentially, in terms of the difficulties of running kdevops, the first run is really a pain in the ass. After that, it just gets easy and it just works. We've also adopted kconfig for providing variability support and essentially using sensible defaults. Once it runs, I should note that it's uber optimized for CIs. We try to, one way to, in which it's optimized is that we try to share Git trees as much as possible. So the idea is you basically have one large server, and you have basically different users on the same system leveraging the same Git repos. We basically share these Git trees to try to save corporate bandwidth and also just try to be efficient and reduce latencies for your CI timing, the amount of time it takes to run a CI. So as an example, if you have the /mirror directory and you have these Git trees, and it'll basically assume that you want to leverage them instead of actually Git cloning from the internet. So it actually supports mirroring all possible Git trees that we support in kdevops on one big server. And this is really simple to set up. All you got to do is make dev config -mirror and then run make, and that's basically it. You're now mirroring all the Git trees that you likely would care as a Linux kernel developer. We also support setting up an NFS server for you. So that way, if you're on a company system on a big RN server, you can just do this in one big server. This sets up NFS for you, and now you just mount this NFS path for all your other servers that you have in your network. That allows you to just have one point so that we can basically just use Git mirroring for all the other servers that you have in a corporate network. It's deterministic. So the goal here is to have determinism for CIs. We learned that Linux distributions have many bugs. We had earlier talked about that, right? That's why I was asking about which version of Debian you were using. We've also learned that essentially you want to try to also use Debian testing on a lot of CIs and using a lot of software utilities that people want to run their own testing for things outside of self-test, for instance. You want to be using something like Debian testing. Otherwise, then it's just going to be too old. So there are bugs in Debian testing, though. It's a pain in the ass to deal with it, but we're dealing with it. We just work around them day by day. Feature and optional support for NixOS is something that we've evaluated to try to get rid of those pesky distribution bugs. I know that some people are using NixOS even for firmware development as well, so which is appealing to me, given that if they're succeeding, that means that we should be able to reduce some of these crazy, stupid bugs that we have in distribution. So that's something that we're evaluating to enhance determinism also for our CIs. So at its core, kdevops is basically a kernel automation framework for Linux kernel developers by kernel developers. We currently support these different workflows. Filesystems was the first one that we wanted to support. Block test is supported, self-test CXL, PyNFS, NFS test, LTP, GetR, sysbench. Future upcoming workflows are testing mmtest and also starting to add some AI workflows. We essentially just want to automate everything. kdevops, I consider it a Linux software 3.0 enabler. Andrej Karpathy is an AI research founding member of OpenAI, ex-Tesla AI lead. He's coined the term software 1.0 to clarify that it's basically just essentially manually written code. In 2017, he talked about software 2.0. He basically has been using this at Tesla, and then it's also being used in other places, but Tesla is one of the places where you can essentially use a neural network to train how to write code. He recently coined in 2023 software 3.0, which is essentially the idea of programming carefully with English. And then he also was the one who coded vibe coding. You guys perhaps have heard of that term. Vibe coding is essentially loosely prompting and hope that it just works. So this is one of my favorite tweets from him. It's basically the hottest new programming language is English, and that's probably true today. So our goal is really to try to automate everything. We strive to write code once and then just automate afterwards. Let's do a case study just to try to evaluate what we did and what I'm talking about here. Sysbench TPS variability is something that we tried to implement to try to do an evaluation of large atomics on MySQL and PostgreSQL. So as an example, as to basically write the code first, this is one simple example type of bash script type of old school way of doing the software 1.0 type of work. And the idea is, can you ask an AI to just write this and port this to kdevops? Well, the answer is that currently it kind of sucks. I give it a grade of D-, but still it was a decent job to try to actually get ported to kdevops. But for plotting, it was pretty amazing. So this will only get better, and I would like to recommend people to start considering this and basically just start using AI agents to try to do your porting of whatever it is that you have in bash scripts to anything that you want. kdevops is one example target. If you're interested in that, just talk to me or use the examples that we have in the commit logs. So let's review some of the challenges, though. We want to essentially create determinism for non-deterministic workflows. What do I mean by that? Well, file systems and memory management are complex subsystems that essentially don't really have a clear definition of what pass or fail, kind of like Tim was talking about earlier. But with file systems, you have a huge number of tests that you essentially, some of them will pass, some of them will not, and you just can't be sure. You really just have to run things over and over and over and over and over again. So let me show you some cool dog tricks that kdevops has. Let me show you how AI actually succeeded in generating automated graphs for us. So this is our evaluation of essentially doing a performance analysis over 12 runs, 12 hours of a run, trying to evaluate the empirical evaluation of 16K atomic writes using DirectIO and MySQL. And basically what you see here is when you have the atomics enabled and when you have it disabled, and basically the less is just crappy, right? And you have less thickness in the bottom and on top, so obviously that's better. This is on AWS. We support AWS. So this was run at AWS to basically just pick a random baseline that we can leverage and enable the community to easily reproduce anything they want. So if you want to go and test this, you could just go ahead and do so yourself. This is something that hyperscalers have been supporting for years. So this is about like 6 years ago that Google started this, and then everyone else followed suit. We also did the evaluation of PostgreSQL for exactly the same thing. However, getting to the point where we can support this in the kernel will require a bit more work. But here's just some splashy graphs that kdevops can generate for you automatically for Sysbench, for instance. And there's other fancy things, so it's possible, done. How do we make file systems test easier, though, if we want to try to automate things? Well, you use kconfig. Here's an example of different types of file system configurations and how to define them. You basically just define the specific commands that you need and the different sections that you want to support, and that's it. Turns out that C coding for AI agents, it's pretty hard today for AI agents. Sometimes it succeeds, but these days, it's getting better. It's only going to get better. English, I give it a B. Writing kconfig, A. So I'd encourage you to leverage kconfig as much as possible if you want determinism and start using AI for automation. It forces also you to write documentation, as an example right here. It enhances determinism and enhances automation. And I do believe that essentially we can use a SAT solver for integration for all these things. I know that there's some reluctance maybe about this, but there's a link here. If you follow the slides, I uploaded them. You can follow the link in the discussion of what I see us being able to use it for. More details and links if you guys really want to follow the SAT solver support. This was contributed by Ole Schursk from University in Germany. And if you want to see more details of the status of the SAT solver integration to Linux, there's links there too. We already forked kconfig as well too, because essentially there was a feature that we needed to support to try to reduce the amount of code that you needed to actually implement. So we want to essentially just make it easy for you to automate things. So one of the ideas here is, what if we just put something at the bottom of a kconfig symbol and said output YAML? So that basically allows us to easily translate a kconfig symbol into YAML. That's basically it. And now we can use this in Ansible. That means that you have less code to write and make files. So as an example, let's follow some of the ideas that were talked about earlier. You should be able to use a SAT solver eventually to just describe your CI goal, your file system configurations, the test suite that you want to run, and the specific tests that you need. So talk is cheap now, right? I mean, how has this been used for something productive on Linux? So let's do another case study example here. LBS support for file systems went upstream on 6.12 release of the Linux kernel. It was a 17-year community development effort, which was finally completed. Required careful page cache and memory management changes. The baseline that we produced was on XFS with 20 different XFS profiles. We started only with XFS support. There's 0 outstanding regressions. Now, moving forward, LBS support for block devices went upstream on 6.12 release of the Linux kernel. That's essentially to support the block sizes to be greater than your page size on the block layer. It required changes for large Foley support in buffer heads. This is ancient code. It was really, really a pain in the ass to do. All block drivers now support this. And as an example, even though we were confident in the testing that we put into it, after this was integrated into Linus's tree, we did get a syzbot report. Syzbot is excellent at finding these creepy, crazy bugs. They're just lovely. It's one of the most complex bugs that I've ever dealt with in my life, actually. So much so that I needed a separate Git tree just to describe all the different types of corruptions and how you can run the corruptions for one specific ext4 profile using a 2K block size file system. It takes 12 hours to reproduce. It's insanity. So how can you reproduce this insane bug on kdevops? This is it. That's it. And we basically use ChatGPT to use an analysis of all the different log outputs from the different corruptions. That actually helped to try to root cause the issue and try to figure out what the hell the issue was. Turns out, it basically was just a workaround that was implemented using Foley migration as a workaround for the bug. The bug wasn't actually fixed. Foley migration was essentially just disabled as a workaround. It was really complicated to fix this. It really required different community experts to jump and get involved on this. So it was fixed, and as a matter of fact, as an aftermath of this, we also enhanced the buffer head path. So it would certainly be impossible to have achieved this without the efforts on kdevops and the efforts that we had for the LBS and the baselines that we had. So I can proudly say that we have 0 outstanding regressions so far on both fronts. And I want to give a hat tip to Dave Lorbueso and Giancarlo for helping on this insane bug hunt. It was really insanity. So this is another case study example where, we have automation in different parts of the kernel. Sasha, this is one example where there's a fix that's identified, but in this case, it's something that wasn't really intended to go in stable kernels. It's difficult, but we want to curate this eventually to enhance the autocell process. So essentially, we need more work in the automation process here, and we need ways that we can identify that specific fixes don't really need to apply somehow to stable. It's not really clear how to do that. We also have this thing called kdevops results archive. We basically needed a home to archive as much data as possible for all the results of the tests that we're doing. We needed infinite storage. We need results to be collected automatically. We're kernel developers. Write me a dashboard automatically too. Wouldn't that be nice? We're kernel developers. Write me a CI stuff too. Just use AI for all this. Wouldn't that be great? Okay, that's the goal. So essentially, that's what we have now. We need a home to archive as much data as possible. We need infinite storage. Well, that's basically resolved through Git LFS. Are folks here familiar with that? It's basically an end server optimization that you can use, and hyperscalers love it if you can actually use that as well too. We cheat. Basically, all we do, as soon as we run out of space in one Git tree, we rotate. Problem solved. kdevops result archive for XFS, this is an example of what that looks like. We then end up with two things. One is the CI ephemeral results, which are basically artifacts that just disappear every now and then. Then we use our own kdevops results archive to basically store persistent results. Here's an example commit into the Git tree. This is directly from the CI mechanism. It just commits it to the repository and lists all the results. So it goes on forever, right? Because XFS is one of those file systems. We have so many profiles. We have 20 profiles that we test. It takes forever to run these tests. 27,000 tests, as an example. 302 failures. So we have also used this to obviously test other file systems. We needed to test this also on ext4. That's how we actually got bufferhead support first. We wanted to stress test bufferheads. And I ended up deciding to just send a mailing list to email to the different file system communities about our baselines. And I asked essentially, do you guys find this useful? Do you want us to send this more to you guys? And the answer obviously is yes. So the dashboard, how about a dashboard? Wouldn't it be nice? Well, who the hell has time for this? So I'm not going to have any shame around this. I basically just vibe coded it with Cloud AI. I'm really happy about the results, and I think that's just the way to scale. So the entire dashboard is generated on every single commit into kdevops result archive. It takes about 1 second. We only process the commit log for parsing results. That's it. Simplify it. The tarball of the results are part of the commit. There's also the respective kdevops config that you can use to reproduce on a specific DUT. So here's some examples of what this looks like. AI generated all this stuff. This is on memory management. This is running the tests on MapleTree, radix trees. And here's an example of dashboard results on ButterFS, all the tests that are run, the pass rates, and all this other stuff. More on ButterFS, more. Here are the failures, for instance. Here's the different profiles that you have for ButterFS. And now, let's talk about KPD. Thanks for the talk earlier, and I think hopefully this will be a bit clearer. We want to essentially automate these tests also posted on the mailing list. Wouldn't it be nice if we can also not only test Linus's tree, but also patches as they're coming to the mailing list? That's essentially what KPD is for. So if you're a kernel developer and you want to leverage KPD, you can essentially use kdevops for this. We have KPD support and KPD integration support. Now, not everyone wants to use KPD, but if you do, it's there. If not, then all you do, you go on the left side of this graph, which is basically you just push the branch development changes that you want into the Git tree, and the same exact thing happens, which is basically the tests just get run. So, for instance, I think for stable kernel maintainers, it might be useful because basically all we got to do is just give you access to these repos. You push, you test, and now you have all the file system results. Eventually, this goes down to kdevops result archive, so top, and then goes down, and that's basically it. This is what the entire diagram looks like, but I figured I'd increase the font size earlier. Hopefully that's a bit clear. If not, let me know. Wouldn't it be nice if you can also use the GitHub CI to also customize your tests? Done. Basically, just select what it is that you want, and that's basically it. You just basically leverage the fact that you have implemented everything in kconfig, and now you provide the variability through a CI. This is what it looks like if you're actually running the tests, and you want to see what the status. The latest dog trick is that accepting the fact that CI development is a pain in the ass. Who here has worked on GitHub CI stuff? Anyone? No? Well, you're lucky because it's a horrible nightmare. It's a pain in the ass, and it's really difficult to troubleshoot. So really, it would be nice if we just didn't have to do it. So yes, there's certain aspects of it that you can do with vibe coding, but it's really painful to test anyway. So AI code is not going to get it right. So it really is the nastiest part of automation. So the goal here was to try to avoid developers having to touch it. So the idea here is one CI to rule for them all. I was hesitant to really expect that we'd get here so fast, but Daniel Gomez really did a heroic effort here to try to work on this, and yes, it's possible today. So essentially, we end up with just these few make commands, and that's basically it. You do your mapping of those respective trees or tests that you have to the specific name of the test that you want to run, and that's basically it. If it's a self-test, it's a self-test. Otherwise, then it's very specific to, let's say, a file system. It's running a fast test. The workflow is a fast test for a file system. And then you have respective .config on kdevops for your file system. Now, how does this fit to kernel CI? Well, basically, the idea and hope here is that we can get kernel CI to also process our kdevops result archive XML files. And that's something that we hope we can collaborate with kernel CI folks on. And also, there's a community dashboard presence in kernel CI for kdevops as well. So right now, it's just a link. I'm not sure if there's future integration. kdevops also has regular testing now. We started basically just leveraging all the work that we've done to basically run tests every Monday on Linus's latest RC tags. And we also run every single Linux next tags now. Currently enabled in this pipeline is basically modules, tempfs, and block tests. Eventually, we'll queue these other subsystems that we have. and then we'll basically just have this all integrated into the dashboard as well. So you need bare metal to really run this because this is really running on virtualized servers. So I'd like to thank my company, Samsung. Intel also has recently decided that they would like to help here. So thank you also, Meta, for introducing us to the folks at Intel on this and joining the effort. So the question is here too, who else wants to join us? If you think this is a good idea, can you help with resources? If you would like to, please just talk to me afterwards. This is completely community driven. And just come automate with us. Any questions?
So I apologize, but I didn't follow exactly what's going on with the kconfig stuff. Are you suggesting is an LLM generating new kconfigs for the Linux kernel?
No, so kdevops adopted kconfig. So essentially, you can leverage kconfig. We essentially took kconfig from the Linux kernel, extended it with this output YAML thing to enable us to also make it easier to run Ansible tasks. So essentially, your DUT, the target that you want to test, is defined automatically by inference when you run make menu config. You can also specify your requirements in a dev config for, let's say, a specific workflow or a file system. You can define, if you are XFS, you want to test it, then basically you are a file system. You want to run the FS test workflow in kdevops. And then by default, you can run all these different profiles in XFS, for instance.
Okay, so you're just using the kconfig file format for test parameterization.
Exactly.
Okay.
And my argument here is that allows more automation and reproducibility as well.
Okay, thanks.
This is where I think that there's a connection between the kernel's config and the test config, and using a sat solver long-term likely will help too. Any other question? Great, thank you.
Thanks a lot.